NASA's James Webb Space Telescope has hardly opened its eyes, and the universe it sees is newer, more mysterious, and more beautiful than humanity's dreams. The largest telescope ever flown, launched into deep space on Christmas Day 2021. Its primary mission is to reveal the "let there be light" moment when stars and galaxies first ignited after the Big Bang. Recently, we got to look at some captivating images as Webb peered back toward the origin of everything. This is one of Webb's early deep dives into the cosmos. 250 hours of exposures that expand the imagination. All these little dots are stars, all these little dots are galaxies, some of which are bigger than our own. Astrophysicist Brant Robertson flew us through 130,000 galaxies, half never seen before, enormous swirls of billions of stars each, some like our Milky Way, and others truly out of this world. We call this galaxy at the center of the screen the cosmic rose. Just by chance, it looks like a rose. You can see that dusty red irregular galaxy, explains Robertson. Space is more crowded than you might think, and galaxies wind up interacting with each other. They actually will merge together. Robertson, of the University of California, Santa Cruz, helps lead Webb's most ambitious mission, the Advanced Deep Extragalactic Survey. Well, we've discovered the most distant galaxy in the universe, the one that is the furthest away from us that we currently know about. I'd like to share that with you. Can I show you some pictures? As we zoom in, we keep going, and now this red splotch that you see there, that's a galaxy that is more than 13.3 billion light-years away. How long after the Big Bang, the beginning of the universe, did this galaxy form? It's amazing. It's only 320 million years after the Big Bang, the most distant galaxy so far. They on the right doesn't look like much, but astronomers can fill textbooks by analyzing the spectrum of its light. So we can actually measure things like how fast it's forming stars. We can measure the number of stars in the galaxy. We know the size because we know how far away it is, and we know the typical age of the stars in the galaxy. So we know a lot. The earliest galaxies so far formed when the universe was 2% of its current age, and the baby galaxy ignited stars at a furious pace. It's like a hummingbird. You know, the heartbeat of this galaxy is so rapid. What do you mean by that? Well, this galaxy is forming stars at about the rate of the Milky Way, even though it's 100 times less massive. So, it really is like a hummingbird. The heartbeat of this galaxy is racing. T-minus 30 seconds and counting. More than a few human hearts were racing in 2021 as the $10 billion observatory readied for launch. Wow! Earlier that year, we were among the last to see Webb in California before it was folded into a 15-foot wide nose cone. Somehow, that's a lot bigger than I imagined. 25 years in the making, Webb is named for an early NASA administrator. Northrop Grumman engineer Amy Lowe showed us. Down below, the silver-colored sunshield big as a tennis court and 21 feet of gold-plated mirrors for gathering light. There were 18 of these hexagonal mirrors, but when you fold them out, they all work in concert as one mirror. Lift off from a tropical rainforest to the edge of time itself, James Webb begins a voyage back to the birth of the universe. Webb, lofted on a European rocket into an orbit around the Sun 1 million miles away to set up for observations. Engineers used a star to align those mirrors, but the image was speckled with what looked like artifacts of digital noise, which forced a closer look. These were not artifacts from the detector. These were not strange stars. The whole of the sky was filled with galaxies. There was no empty sky. And that's when I went, this telescope's going to be phenomenal. Matt Mountain leads Webb's operations as president of the Association of Universities for Research in Astronomy. No empty sky? What do you mean by that? In almost every image we're taking now, we see galaxies everywhere. I mean, we took a simple picture of a planet in our own system, Neptune. You know, it was this beautiful orb just sitting there, and we saw some rings in the background. Galaxies again. It tells us that the universe is filled with galaxies. We knew this theoretically, but when you go out to the night sky, we're used to saying, well, look up at the night sky. We see those stars. We can no longer say that. We now have to say, look up at the night sky, and there are galaxies everywhere. We call it space because we thought there was nothing out there. There is no empty sky with James Webb. That is what we have discovered. Matt Mountain says that Webb is a reminder of how much we do not know. For example, galaxies are rushing away from each other at greater and greater speed, defying gravity. It makes no sense. So scientists infer that there must be unseen elements at work. They call them dark energy and dark matter. And whenever you hear the term dark energy or dark matter, this means we don't know what it is. We're not that imaginative, but it is a force. It is 95% of our universe, and we have no idea what it is. Wait a minute. 95% of our universe is made up of dark energy and dark matter, and we don't know what it is. Correct. We're lucky if we even understand 4% of our universe today. Astronomy is a very humbling discipline. Laughter. Humbling. But with Webb, look at this. Also thrilling. Look at this, right? This is Purdue University astronomer Dan Milisevoljevic, starstruck and chatting with a colleague. Yes, the detail, even Wilbur, who's not an astronomer, strained to see what the excitement was about. Milisevoljevic studies exploded stars, which were the furnaces that forged the first heavy elements from a cosmos of simple helium and hydrogen. Every time there's a supernova explosion, it's producing the raw materials for life. The iron in our blood, the calcium in our bones, the oxygen that we breathe. Love that oxygen. All that is being manufactured in supernova explosions. The late astronomer Carl Sagan used to say, "We are all made of star stuff." That's exactly right. Webb reveals unprecedented detail at the center of these explosions, and that's what Webb is most sensitive to for our purposes. Understanding what's happening inside the explosion that we couldn't see before because it only comes out in infrared light. Infrared light is what Webb is designed to see, like a night vision camera. The telescope is sensitive to heat radiation, which is all that remains of the light reaching us from the dawn of time. Trouble is, infrared is invisible to the human eye. When you first pull up the Webb data, what does that look like? Essentially, it looks like a blank screen. Elisa Pagoni and Joe DiPasquale are astronomers and science imagers for the Space Telescope Science Institute. This is what a Webb infrared picture looks like until they match the data-filled darkness to color of wonder. So we take those longest wavelengths of infrared light and give those the red colors. The next shortest wavelengths would be green, and then the shortest wavelengths that we get from Webb are colored blue. And so, just like how our eyes work, we take those three color channels, combine them together to create the full-color images that we see from Webb. Among their favorite images is this cluster of stars with a not-so-wondrous name, NGC 346, cosmic dust sculpted into ripples by interacting actions between stars and the Tarantula Nebula, a star-birthing nursery on a backdrop of galaxies. It occurs to me you're the first two people to see these images in human history. Yeah, it's quite an honor. It is a great honor, and it does blow your mind every time. There will be many mind-blowing revelations. Webb is already the first to find carbon dioxide in the sky of a planet 700 light-years away. It will continue to look for planets with atmospheres that might support life. On the other end of the timescale, astrophysicist Erica Nelson of the University of Colorado, Boulder, thinks her team may have made a discovery that she says would break the theory of how the early universe formed. Either this is wrong or this is a huge discovery, and we think that it's a huge discovery. More observations are needed, but Nelson is investigating what may be 5 giant galaxies that appear to have formed much too quickly after the Big Bang. If they're confirmed, astronomy may have to revise the timeline of galaxy formation. And that's the most exciting piece of this telescope, of this remarkable instrument we put in space. Finding things that we didn't expect, that we can't explain, because that means that we have to revise our understanding of the universe. Brant Robertson, who showed us the earliest galaxy found so far by the James Webb Telescope, told us, "The record for the earliest will not hold long." How far back can you go to the origins of the universe? Well, JWST is so phenomenal that if you spend enough time, you could probably find any galaxy that ever formed in the universe. It's really that powerful. Will the history of astronomy be divided between before Webb and after Webb? Yes, I believe it will be. Matt, who manages Webb operations, told us, "The observatory may last up to 25 years, perhaps long enough to comprehend space and time and the origins of life. We're seeing a universe we've never seen before. We thought it was there, we hoped it was there, but now we see it for the first time. The James Webb Space Telescope represents a monumental leap forward in our quest to understand the cosmos. Launched on Christmas Day 2021, this extraordinary observatory is not just a marvel of engineering, but a window into the depths of time itself. Its mission goes beyond the boundaries of what we thought possible, aiming to capture the earliest moments of the universe and unravel its most profound mysteries. One of the defining features of Webb is its sheer size and complexity. Spanning the size of a tennis court, its sunshield alone is a technological marvel, designed to protect the sensitive instruments from the intense heat of the sun. The telescope itself boasts a collection of 18 hexagonal mirrors, each coated in gold to maximize their ability to gather faint infrared light. When deployed, these mirrors work in harmony to create a single, unified image with unprecedented clarity and detail. Webb's journey to its operational orbit around the sun, positioned approximately 1 million miles from Earth, was not without its challenges. Engineers meticulously planned every aspect of the launch and deployment to ensure its success. Once in position, the painstaking process of aligning the mirrors began, a critical step in ensuring the telescope's capabilities were fully realized. Initial observations revealed a sky filled not just with stars, but with galaxies stretching across unimaginable distances, confirming theories and raising new questions about the nature of our universe. The telescope's ability to peer deep into space and time is enhanced by its sensitivity to infrared light. Unlike visible light, which is absorbed or scattered by cosmic dust and gas, infrared light can penetrate these barriers, revealing objects and phenomena that are otherwise hidden. This capability allows Webb to observe the earliest galaxies, whose light has traveled billions of years to reach us, offering glimpses into the universe's infancy. One of Webb's groundbreaking achievements is its discovery of distant galaxies, some of which formed just a few 100 million years after the Big Bang. These observations challenge our understanding of how galaxies evolve and raise intriguing questions about the conditions that existed in the early universe. By studying the light emitted by these galaxies, astronomers can glean valuable insights into their composition, structure, and formation processes. Astronomers using Webb have also turned their attention to our own cosmic backyard, exploring planets within our solar system and beyond. By analyzing the atmospheres of exoplanets, Webb aims to identify signatures of potential habitability or even signs of life. The telescope's ability to detect molecules like carbon dioxide and water vapor in distant planetary atmospheres opens new avenues for understanding the diversity of worlds beyond our own. Webb's scientific observations are complemented by its role in advancing our understanding of fundamental physics. The telescope's ability to study supernova explosions in unprecedented detail provides valuable data on the processes that produce heavy elements essential for life. These explosions, which occur when massive stars reach the end of their lives, distribute elements like iron, calcium, and oxygen throughout the universe, seeding the cosmos with the building blocks of planets and living organisms. The discoveries made by Webb have profound implications for our understanding of the universe's origins and evolution. By probing the depths of space and time, the telescope offers a unique perspective on cosmic history, revealing the interconnectedness of celestial objects and the forces that shape them. From the formation of galaxies to the birth of stars and planets, Webb's observations provide a comprehensive view of the cosmic tapestry, enriching our knowledge of the universe's past, present, and future. In addition to its scientific achievements, Webb represents a triumph of international collaboration and technological innovation. Built through a partnership between NASA, the European Space Agency (ESA), and the Canadian Space Agency (CSA, the telescope embodies the shared commitment of the global scientific community to unraveling the mysteries of the universe. Its construction involved thousands of scientists, engineers, and technicians from around the world, each contributing their expertise to ensure the telescope's success. The legacy of Webb extends beyond its scientific discoveries to inspire future generations of astronomers and space explorers. Its unprecedented capabilities and groundbreaking observations serve as a testament to human ingenuity and our insatiable curiosity about the cosmos. By pushing the boundaries of what is possible in space exploration, Webb challenges us to rethink our place in the universe and imagine what lies beyond the horizon of our current understanding. Looking ahead, Webb's mission promises to yield even more profound discoveries as it continues to explore the universe's vast expanse. Future observations will focus on unraveling the mysteries of dark energy and dark matter, two enigmatic forces that dominate the composition of the universe but remain poorly understood. By studying their effects on galaxies and cosmic structures, astronomers hope to gain insights into the fundamental laws governing the cosmos. Moreover, Webb's ability to study planetary systems in unprecedented detail opens new avenues for understanding the conditions that give rise to habitable worlds. By identifying planets with potential Earth-like characteristics, the telescope lays the groundwork for future missions aimed at searching for signs of extraterrestrial life. These efforts could fundamentally reshape our understanding of life's prevalence in the universe and our place within it. Beyond its scientific objectives, Webb serves as a symbol of human achievement and perseverance in the face of daunting challenges. The telescope's journey from concept to reality spans decades of planning, development, and collaboration, culminating in its successful launch and deployment. Its ongoing mission exemplifies the power of international cooperation and the boundless potential of scientific exploration to expand our horizons and inspire future generations. In conclusion, the James Webb Space Telescope represents a pinnacle of scientific achievement and technological innovation, poised to revolutionize our understanding of the universe. By probing the depths of space and time with unprecedented precision, Webb promises to uncover new insights into the origins of galaxies, stars, and planets, while challenging existing theories and raising new questions about the nature of our cosmos. As it continues its mission of exploration and discovery, Webb stands as a testament to the ingenuity, dedication, and collaborative spirit of the global scientific community, paving the way for a future where humanity's quest for knowledge knows no bounds.